Okay, so I'm glad we've had these conversations because it helps me to actually go back and look. And what I had done, I actually had to correct a little bit of the headings um, because I had moved. Whenever you move the sun's position either closer to the North Pole or further away from the North Pole, you've got to actually widen them along the compass lines, and I didn't do that. So yeah, so this is a minor correction change, if that makes sense. But essentially, this doesn't change at all. The angle doesn't change at all. What changed is whenever you move the sun's further away from the pole and closer to the pole, the sun here in this model will kind of disperse the further away you go, and then kind of come closer, depending on which latitude you use. So, looking at it from this direction, the closer it is to the North Pole from my position, the more it'll be along these lines. So when I move them across lateral lines, latitudinal, the latitude lines. When I move them across the latitude lines, I have to, as long as I stay on this line, these are the compass headings. So for my location, these are the compass headings on February 12th. Okay, and here's the time. So each, I'm trying to put my finger in there because it takes the zoom, but these are the times of where the sun is relative to my position. So what I did is, because you're asking about how did I do this, so here's the Google Drive that I have. Sorry for everything going crazy. Hold on, let me unplug this. It may help. Here's all the times. So for example, let's do 11:25, and here is this photo of 11:25. So what I did is I pointed this speed square at the sun, and it's got a level down there, so I know that the speed square is level. And then I just took the picture, and then in CAD I drew a straight line from that point right there straight through the sun, and then I could see where that line went to on the speed square. So if you go, I actually started it here because it was a little bit easier to get to, but again, leveled speed square, pointed at the sun, drew a line from here straight to the sun in CAD, and here's all the sun photos from different times in the day. I took several, so yeah, and that was a mess up. That was another mess up. Okay, there's my compass, showing where my compass is. So on and so forth. There's where my compass is, and there's the sun. Okay, so this is all at 11:25. Okay, so everything in this folder is what I did at 11:25. So if you go back out and you do like 12:45, here's the photos that I did at 12:45. And again, taking this and just drawing a line straight through the sun in CAD, and then got my measurement. So there's the 12:45 photo, 1:45 photo. You see how the sun is changing positions relative, so on and so forth. So yeah, there's 2:45 there. I actually didn't take the picture of the sun at 2:45 for whatever reason. But yeah, there's 3:45. So now you can see it's going off. So this is the west. So this line pretty much points east to west. So this direction is going west. But as you can see, if you see all these photos side by side, you can see me constantly turning the speed square and taking a photo so I can measure the angle. So this is how the angle was measured. And then, of course, the compass, again, you can tell pretty much this is pretty much square, going east and west, and that's where I did the compass heading directions there. So yeah, just use this compass and a speed square, and then plotted the courses in there. And as you can see, as I brought them out further away from here, and then so I had to make them wider. So yeah, so that's all you gotta do is just take the photos, take the pictures and the measurements at each time, Again, I have, you know, the times here, plotted them in there. And again, like I say, this is a little wider, but when I was talking about the angle, the arc, not the angle, you still have this arc. Now, depending on where you want to put the sun, the arc is going to be closer in, further out, the sun will be further out. So, again, nobody can tell anybody where the sun is on the flat earth map today. We're just going roughly by assumption. So if you want me to put this sun anywhere on a specific latitude line, I can, and we can see what it looks like on that latitude line. So right now it's in the winter months in the northern hemisphere, so that would say, what flat earthers say is that the sun is either going in this direction, like away, circular away from this, because that's how it gets colder. That's how they justify seasons. Or the sun is going up, like at a higher elevation. But they can't explain how the higher elevation works either. So there's no formula that shows the higher elevation. So this flat earth representation is from this. So if you want to tell me where the sun is on the flat earth map, I can definitely put it there. But this is where the sun is with the compass headings lined out here, and the elevations of the sun. Let me get to the side view again. Elevations of the sun as per these photos, just plotted in. So yeah, that's how I did it. And that's how I recommend everybody do it, really. So yeah, so that's where I did. That's how I did it. Got those, put them into there, and I did that in January as well, and I'll do another one probably in March. But you'll notice that as I continue on, the sun will actually be higher up than every month up until June, because the arc, or not the arc, excuse me, the angle moves this way. So there you go. I hope that helps. Sorry it was a long video, but you were asking a bunch of questions, or the same question over and over again, so maybe this will help answer those questions. So have a great day.